Welcome back, Gangies. We're back once again, back to the hyperbolic coding chamber. The easy slang chamber is actually where we're really at. So we're pretty deep on the easy destruction. Things are going well. I think we have 293 now, so almost halfway done with the easies. I think if we had gone back to doing an hour a day. If we got back to doing an hour a day, I think we would finish them in 2 months, which would be kind of dope. I think that would be kind of dope. Because if we do about 3 easies a day in 30 minutes, then in an hour we could do about 6, right? 6 times 10, 60. You could do 180 easies a month. And then from there, it would be 2 months. So I think that would be pretty cool, but it remains to be seen if we actually get there. But I think we are going to be stuck with 30 minutes for a while. I think we're just doing some other stuff that it just gotta be that way, unfortunately. So yeah, but unfortunately it'd be that way. I got some other stuff in the pipeline that I think is going to be pretty cool, but it's just going to take a little bit to get there. So yeah, rip. So yeah, but we do have a comment from yesterday, and yesterday I was discussing the sentiment that there's so much to learn in computer science and that it takes too long. And we have a legendary comment by Wilderness, who has one, if not the most legendary profile pictures of our main man gone. Concerning how broad the landscape is, people have been discussing specialization a lot. Why be average at a bunch of different things when you can be the best at one specific thing and receive disproportional amounts of compensation? True! There are not enough hours to know it all, and no one does. Truer words never spoken. You have centered me, brother. Yeah, I feel like sometimes I end up in a thing where I'll act like it's 100% required to know everything to its fullest, deepest depth and be the best at it. And that's not a good mindset to be in. So I really appreciate this comment. I think it's bringing me back down to earth. We don't need to know everything. So, and I always forget that. So you just need to know a couple things, a little bit, right? And if you want, you can pick a couple things and go crazy at it. I feel like front end is flames. Front end is a good gig. And I feel like I would prefer front end long term. And maybe dabbling a little bit of back end, but I feel like front end is flames, but there's also a lot of frameworks which has made it easier. And it feels like with the current landscape, front end, I feel like nowadays it's mostly like I feel like it's more common to be just both. But that's besides the point. I think we should just learn what we can where we can, which I think is the sentiment Wilderness is getting at here. And I think that's a good way to go. And that's kind of how we got this far. I remember when I first started LeetCode, I was like trying to learn every single thing about everything ever. And it was just too much. And I overwhelmed myself and I was just like, bro, this is the worst. And then we decided to take it day by day. And we've made some progress. So maybe we should just keep with that mindset. And hopefully we'll be able to get to harder problems and keep making some good progress. So I appreciate that comment. I was talking crazy. And this is why we have the hyperbolic coding chamber, to keep us grounded and to keep everyone else in the Discord grounded. I surmise if in my passing, we will pass the baton on to Wilderness. In the Discord, he will continue the daily LeetCode for us, and then it'll be a wrap. And then we'll pass it on to his offspring and their offspring, so on, and on to the Discord HCC's offspring. And then 30 years from now, when there's no point in coding because the human brain computer interfaces have found a way to pretty much communicate with thought, there'll be no reason to do LeetCode. We'll still be doing it anyway. So that would be pretty cool. But that being the case, that's kind of where we're at. Part of me has been thinking we should start doing mediums. But I really wanted to finish all the easies and then go into the mediums. That's what I really wanted to do. But you don't really need to do that many problems that many mediums. I mean, that many easies. But I think the whole thing we're trying to do is do all the problems anyway. So now I feel much better about easy problems. I think we'd originally started this because I felt like I could do a bunch of graph problems, but I couldn't do a basic string or array problem. Or I didn't feel as comfortable as I wanted to with it. Now I feel much more comfortable with it. But also there's a lot of little stuff we got to practice along the way that I feel like is going to hopefully be useful. Hopefully we're working under the assumption that easies are easy problems, and then the mediums are a combination of multiple easy concepts, and then a hard problem is a combination of multiple medium concepts. I think that's what we're kind of working with, and I feel like that could be a cheat code. Unfortunately, though, if we had just done 293 medium problems, we would probably be where we need to be. But it takes much longer to get there than it does with easies. So we have, I really wish we could have known how many we had done so far. What day we started the easies on, so we could project a future day, because it might be like day 300 when we might be like day 400. I think that's what we said, day 400, when we finally get to the mediums. And then we gotta do another 400 days. That would be crazy. That's crazy talk. So maybe we will switch soon. There's some things I'm working on that I don't want to dip on yet. So it'll be interesting to think about. But it does feel like we should probably start doing them soon. Or maybe we can alternate, like easy, medium, easy, medium. But I really wanted to finish all these. I feel like there's another option where we do hunker down. We do like an hour and a half every day. Then we could finish them. But I really just wanted to do all the easies and then do all the mediums and do all the hards. Maybe I'm feeling some external pressure. I think we'll just keep on keeping on. We'll keep doing what we've been doing. And what else can we do besides that? So I think that's what we're going to do. We're going to do our regular 30 minutos. And we'll just try and blow through more problems. Well, not blow through. Some of these problems are actually were really good. So you're given an array of equal length strings. Equal length strings, words, ADC, WZY, and ABC. Assume that the length of each string is n, the length of each string is uniform. Each string, word sub I, can be converted into a difference. Each string, word sub I, can be converted into a difference integer array. Difference sub I of length. Difference sub I of length n minus 1. All the strings in words have the same difference integer array except one. You should find that string. Return the string in words that has different difference integer array. So you have ADC, WZY, and ABC. The output is ABC. The difference integer array of ADC is 3 minus 0. Where is 3 coming from? Oh, 3 must be D. 3 minus 0. Two minus 3. Okay, I think I see what they're saying. So we just have to return the string that's not the same as the others. So we could just load all their differences into a map, right? Where we'd map the string to its difference array. Or we'd map the difference array to the string, and then we just return the key with map diff array to string, then return key with with string array of length 1. I think this makes sense. So we'd have a map then. It would be a map of string to, we'll just make it an any array. And then we'll do for const word of words. Let's say if map already has the array diff, right? Then we want to get that array, which should already exist. Otherwise, we'll create an empty array. We're going to do map.set. R, and then we can do for const key, and I will do for array diff words. We will return and then I think all we should have to do is make that string. I'll make that function, it's going to return a string. So we're going to iterate for const letter of word. And the diff is a tuple that we're going to return as a string. Not really a tuple, but I guess an array. Do r dot push r sub I minus r sub I minus 1. Our output is undefined, so let's see what our array diff is. Something is very wrong here. Oh, I'm saying r sub I. Yeah, I see what the problem is. We need access to, what I really mean is we need the integer value of where the number is. We pretty much have r sub I should not be r sub I, should be word sub I, but the issue being that it's not an array, it's a string, and we need to get the ASCII representation of where the letter is. So I think we can get the same value if we do from I think if we do word sub I car code at that zero with that ith index to get the car code. But I know capital A starts at 65, so we actually have to do two uppercase, which is a little bit messy. Word sub I dot two uppercase. Word sub I dot two uppercase. Car code at 0 minus 64. Minus 65 probably. There we go. I knew we were onto something. So it looks like this is acceptable. Nice. I think we did largest triangle area. So we have to find the distance value between two arrays. Given two integer arrays, R1 and R2, and the integer D. We're given two arrays of numbers with the number D. Return the distance value between the two arrays. The distance value is defined as a number of elements R sub 1 sub I such that there is not any element R sub 2 sub j. Where the distance of the two numbers or even if you were to subtract the distance, it wouldn't be less than or equal to D. So D is 2 here. And if you do 4, pretty much looking for all the ones where the distance the number of elements such that R sub I minus R sub 2 sub j is less than or is greater than D. So we need to count the number of elements which is greater than D for any arbitrary index. For R sub 1, for R1 sub 0 equal to 4. All of those are less than D, less than or equal to D. Oh, no, they're all greater than D. And so we have two values where 8 minus 10 how is the answer 2 here? If we have two of them that are breaking the, if we have 3 of them that are breaking the rule. I'm not following. The distance value is defined as a number of elements r sub I, so r sub 1 sub I, such that there's not any element r2 sub j, ri, r1 sub I minus r2 sub j less than or equal to d. Oh, it's a number of elements that don't break the rule. That makes sense. A number of elements that don't break the rule. Okay, so I think you can do this in while the math the absolute value of r1 sub I minus r2 sub j is greater than d, do j plus equal 1. Then we'll say if j equals r2 dot length, right, then we'll do distance plus equal 1. So you're iterating over all the numbers in R1, and we're going to iterate over all the numbers in J. And if the value is greater than D, we'll continue. Otherwise, we won't. So for J would be equal to 0, which is R2. Right, 4 minus 10, the absolute value will give you the difference. Is it greater than D? If it is, we'll do J plus equals 1. At the end, when this ends, we should have 0, 1, 2, 3. We're at 0, we check it, we go to 1. 1, we check it, go to 2. 2, check it, go to 3. So we have to decode the message. You are given the strings key and message. You're given the strings key and message, which represent a cipher key and a secret message. Respectively, the steps to decode message are as follows. Use the first appearance of all 26 lowercase English letters in key as the order of the substitution table. The first appearance. Align the substitution table with the regular English alphabet. Key is equal to happy boy. Actual key would have at least one instance of each letter in the alphabet. We have the partial substitution of H to A to B, P to C, Y to D, B to E, and O to F. Looks like there's two phases here. The first phase would be creating the key map of secret letter to real letter using map to decode message. To do the first part, we need a map where the secret letter, or the key letter, maps to the real letter, which is probably a better way to say it. So in this case, H maps to A. H maps to A, which means you could have a variable outside, which would indicate the beginning ASCII letter, or the offset, so 0 to 26. Then if we haven't seen the letter before in the set, right, then if we haven't seen the letter before in the map itself, then we can add it. So I think that makes sense. We're gonna need access to a map of string to string. So we have the letter of a key, right? We're gonna say if key to real, right, doesn't have letter, and it's gonna be all lowercase, then we need to map it to its ASCII offset. So you can say key to real, let's set letter equal to string not from car code 65 plus ASCII offset dot to lowercase. So we have decoded, and say letter of message right? We want to ignore if it doesn't equal a space. Well, if the letter equals a space, right, we're just going to say decoded plus equal a space. Else we're going to say decoded plus equal key to real dot get letter. Oh, and I forgot to increment ASCII offset. Nice. So we have like 41 seconds left, and I think we'll stop there for today.